Hey, hi, welcome to a session of exploring insights using AskPrisma. AskPrisma is your multi agent AI for data analysis. Today, we have a very interesting data set. This is the hypertension data set from Kaggle. It has quite a few interesting fields, age, different factors, and also whether the person eventually had hypertension or not. Let's explore some insights from this data. Can you please help me figure out factors that affect hypertension? Also, do the this is by age group. Let me also say create some slide deck for this exploration. I'll let Ask Prisma now. Like every session, Ask Prisma will create a Docker container, will upload this data set to the Docker container, and then start exploring the data set as within this isolated Docker container. Within AskPrisma, you have multiple agents. You have a planner agent. The job of the planner agent is to analyze the task from a business and a domain perspective. The planner agent internally will work with the code assistant and the executor agent to actually run Python code and execute this data. For now, I'll just say please proceed for now, and we'll go through the plan. So the planner agent has looked at the data, the granularity of the data, and all the columns that are there. Based on this, it has come up with a plan to achieve this goal of ours. Largely, it's going to do a little bit of data preparation, create multiple category groups, do a univariate analysis using box plots in this case, do a logistic regression, and then eventually keep on going till the time it's figured out any patterns within the data, and eventually it'll try and come up with an extensive slide deck of the exploration. So it's already started creating some visualizations with hypertension, without hypertension. It started plotting and graphing individual factors already, right? We can also, expand this and slowly look at all of these factors one by one for quick visualizations. So this is by every factor. Nice. And then if you notice here, this is almost like autonomous agent where he actually is working on the entire task start to finish, and it keeps on synthesizing insights on the data. If you notice here, these are insights that it has captured from these explorations. If you feel you're probably well versed with Python, you can also expand this block and see the actual Python code that has run in the background. So it has done quite a few visualizations. Once in a while, when it feels that it really needs to change, revise the plan based on some interesting factors, it can come back to us. You can say, yes, this look feels right. So it's already started to figure out aspects around what factors are leading to hypertension. Nice. Yeah. So I think it's a really thorough analysis of the data. Like every other data analysis, insight generation exercise, you have to build hypotheses and then you have to revisit those hypotheses. At this point, it's also trying to combine it into a slide deck with summaries. Slide deck is ready. We'll expand this just to look at it from a full screen perspective. So, what drives hypertension factor age analysis by age group? So, it's actually looked at the entire age range. These are intermediate factors, genetics and behavior major risk factors. So, it's figured out that a family history nearly doubles the rate of hypertension. A 38% weakened genetic predisposition plays a substantial role. Smoking looks like a standout factor. This one is like the deeper statistical logistic regression based analysis. This error bar chart shows adjusted odds for six top predictors. It shows both family history and smoking have the greatest impact. Effect sizes are even larger in older groups. Stress, sleep, and salt retain strong and consistent effects across all ages. And these are key insights. Smoking in families are strongest. Stress and salt have particularly strong effects, suggesting early lifestyle modification is still vital. Mid to smoking genetics, cumulative lifestyle risk magnify sleep deficit shows increasing risk. Exercise and meditation after adjustment, these factors did not show significant and direct impacts, which is again from a statistical perspective. Launch age-related smoking cessation programs, implement stress management, salt reduction drives, screen and target at-risk individuals with family history, promote sleep health, education in all wellness groups. Looks good. So we probably spent like 5 to 7 minutes, and we've had a really deep statistical analysis of this data. Hope you enjoyed it. And if you have any data analysis based tasks, you can sign up with AskPrisma and give it a try. Thank you.